Yeah, this goes negative very quickly.
Mr. B,
Yes.
What should we put in for the window?
That's what I'm kind of trying to fiddle out here.
So I'm assuming we need to find the x-axis,
Oh, okay, I've got some stuff here. I see a little bit what's happening here.
What's the question even asking us?
Okay, guys, you need to change. Okay, now, there's a couple things here. Does everyone have a calculator out?
Yeah.
We're not asking a question, we're just seeing if we can graph this. Everyone who has a calculator out. Okay, go to Window.
Yep.
Okay, go to Window. I'm borrowing your calculator right now, so sorry. Go to Window. This window has a T-min and a T-max. Okay, so even though you can't see T, it's your parameter, you can't see it, the T-min and T-max tells you how much, over how much time the calculator is going to worry about what you're talking about. Now this thing's probably not going to be in the air more than about 10 seconds, so I would say go from 0 to 10. Now here's the important one, T-step. Your calculator wants to know how big a jump to make from each step, okay, between each T values. If you use a large T-step here, then your calculator will jump. What was happening with the line you got, Ramsey, is your calculator was jumping from like the first point to the last point without drawing the parabola in between. It won't draw in between the points unless you tell it to. So put a T-step of 0.1.
Mine's already 0.13089
Yeah.
6 ...
Okay, well, let's all have the same one. That's pretty small, and you should have a parabola.
Yeah.
Now, let's start looking at the window. For x-min, go ahead and put 0. We don't need quadrants
Wait,
2 or 3.
0.01? Or?
0.1. 0.1 should be fine. 0.01, and your calculator will spend all day figuring out every little step,
Okay,
which
so
it also doesn't need.
what about the x-min and y-min?
Well, x-min, I'm just putting 0. X-max, I'm going to try, let's see, it's 50 meters per second. If it's in the air 2 or 3 seconds, it'll go 150, 200 meters.
For X-Men?
0. So I'm gonna go ahead and do 200 for my x-max. I'll leave my x scale at 1. For my y-min, I'm also going to do 0, because I don't care about anything negative here.
Wait, what is the x scale and y scale?
It places the tick marks that far apart on the axes.
It's a parabola.
Now, for my y-max, I'm going to do 50, because I don't really know how high this is going to go. I'll leave my y scale at 1.
Graphing. Oh, I see it. I see
And
it.
I'm getting a parabola, and wow, my y scale's way too high. I'm going to lower my y scale to,
I'm not getting. Wait, why is the x scale? It's like weird. It's only in the corner. See?
Okay, I got a different parabola. If I double check how you entered it. I'm not sure about that.
A triangle thing.
Lower your T-step. Shrink your T-step, because it's probably drawing lines between them. I just found, I got a better idea for the window, looking at this.
I did 20.
I'm going to get my Y-max just up to 20,
That's what I did.
because I think Sarah's right. And my X-max will only be 150.
Oh, I got a nice
Wait.
little thing.
Wait, the Y-min would be what?
Yeah,
Wait,
Y-min would be 0.
Y-max is 200.
I'm still only getting like half of the parabola.
Yeah, it's interesting there. I'm going to take a look at yours in a sec.
It's like the other side is on the other side of the y-axis or something.
Yeah, it doesn't look centered at it. Okay. I've got a nice parabola up here.
I'm in
Let me see if I can
extreme amount of pain.
get it.
Why do you stay home?
'Cause
Okay.
I wasn't even sick.
So for your window,
Why do you get some sleep?
That's so weird. Look, I didn't even get a parabola. It's a single line.
that's a parabola. It's just only half of it though. I think that might be what you've entered, sweetie. Take another look at what you typed in.
Well, for the x, it's 0 plus 15 times cosine 15t. And then for y, it's 2 plus 50 sine 15 minus 1/2
Okay, look.
times
Okay,
9.81.
Kath, it's really not helping me to hear it. Okay, you take another look at it to yourself. Okay.
I'm sure I put it in right.
X-min
It's like, wait, x-min.
0. Hang on. X-max
X-min.
150. Y-min 0.
Wait, maybe that's the
Y-max 20.
Why not?
This gets me a very good view of this parabola. Now, I think we actually went a little bit too far, but let's take a look at this. Here you go. I'm going to...
Wait, you need both of them in order to graph this?
You mean X and Y?
I see it.
Yes, you need an X and a Y.
Oh my goodness.
If I took away one of them, if I took away like the Y, would I have just a straight line in the X direction?
No, if you put it away, you'd get an error, I believe. But if you just put Y equals T, then you'd get that line as if this were x equals 50 cosine y. That's actually an interesting way to graph non-functions. We'll get to that in pre-cal later, Ramsey. Okay, but for now, let's talk about this graph a little bit. What happens when you hit trace? What do you see? Normally, trace gives you an x and a y, right?
T0,
Wait,
x0,
Mr.
y2.
Yeah.
I'm
And
like
then a huge equation.
totally sure that I entered this in right. I just double checked it.
Let me double check, Bessie. Okay. You left out a t.
What do you mean I left out a T?
You left out a t after sine 15.
There's a T there?
Yep. It's right there.
Wait, where? Donde está?
It's up there. Okay. Now you have to get that window to look like ours.
Donde
Okay.
está?
So hit the trace button, and what are you looking at? It says a t, x, and a y. Now normally with the trace on your calculator, you put in an x value and it tells you the y, correct?
Correct.
So wait, which kind of window should I have?
Hang on a second. Let me get this point. So now trace, you put in a number when you're in trace mode now, and it'll give you a t, which in this case is a time. So you can put in a time, and it will tell you how high what you've thrown is and how far it's gone. So start playing with the trace mode, and I want you to tell me in a minute when I ask, at how many seconds is this thing at its highest point, and how many seconds go by before this thing hits the ground?
Oh, I see how to work this.
Okay, how many seconds go by before it hits its highest point? How far before it hits the ground? And did we go way too far by having our t-step go up to 10 seconds?
Well, I can't see. It's 2.8 seconds.
What happens at 2.8 seconds?
It reaches like.
The
No,
highest?
I got 1.3.
Yeah, I got 1.3 for the highest.
Oh, the highest?
Yeah, what is 2.8 how long it's in the air?
No, I'm saying like. Yeah.
When it hits the ground,
Yeah.
it looks like it hits the y-axis?
Yeah, it looks like that.
Okay, so it looks like its highest point,
Well, the closest it will get is like 2.75, looks like.
okay, so its highest point is at approximately 1.3, you guys said?
Yeah, 1.3.
Yep.
1.3 seconds, and its time
2.8.
in the air is about
2.75?
2.8 seconds. So you see how the TI-83 can analyze ballistic trajectory for you?
You're a ballistic trajectory.
As long, throw me off out of catapult, and I will be.
Is that why people call it?
A trebuchet.
Is that where the word? Well, what came first, ballistic trajectory or the word ballistic? Like to go ballistic?
I think ballistic trajectory came first.
Huh, it's fun.
I think ballast actually came first
Yeah, I was
on
thinking
ships
is
and
it
balloons.
or like, could it be a ballista?
Could be
Yeah,
the
maybe
old
a
the old
ballista.
weapon.
Yeah.
Yeah.
You know so much more about that than I
Maybe
do.
it's a
Noah.
beluga whale.
Ballista.
Sure. Okay. So now you see how you can set up these equations in your TI-83 calculator, and you can hopefully answer the questions. The questions, starting in the homework tonight, are similar to the questions you've had in the past, except now things are getting thrown at an angle. They're not all horizontal launches. We can now do angled launch. Does that make sense? Incidentally, but this is last bit of obscure math point. This is the real reason why René Descartes decided,
Who is a dude?
who was a dude, René Descartes, this is why he decided to have the unit circle start at 0 degrees being horizontal and go counterclockwise. Because this makes all the trigonometry work with launch angles. This way, this is what makes the trig work for a 15-degree angle always being above horizontal, making these equations work correctly. If he had started at north like a compass and gone clockwise, then we'd have to use different angles to make the trig work on ballistic trajectory.
That would suck.
That would suck. So he was thinking it out.
Which math sucks anyway.
Personally, I think when he figured that out, everyone should have switched, and we all should have clocks that start 0, where 3 o'clock is, and go counterclockwise.
That'd be interesting.
I'm going to get clocks like that made.
You're gonna make
You're gonna kill yourself. You're gonna be late to everything.
I know. No one will ever know what time it is. All right.